I think we don't have much time today, so let's start like right now. Some logistical problems, so we had to switch the talks. Today I will be talking about the security, and we'll focus on real-life use cases. So short introduction, I'm Johannes. I've written most of the security component, and I also have a GitHub account, a Twitter account, Johannes MS, and Schmitt if you want to add me. So that's also about it. Then we're going to first talk about the authentication system in Symfony 2, so that you get a better overview of which classes we have and what they do and what dependencies they have. Then we're going to talk about the authorization system also really quickly, like what classes do we have, what are they doing, and then we're like most of the session focusing on real-life use cases. How can you apply the security component to certain needs that you have in your application? So let's start with the authentication system. Basically, how it starts is with the firewall listener, which is triggered on the kernel request event, and basically, checking which configuration do I need to load for the current request. And it does that by loading a firewall map, which basically is just a container which encapsulates your configuration for security. Like which listeners do you have, which authentication methods do you want to use, and so on. And basically, what it returns is an array of listeners, which we call sequentially, in order to process the security aspects of your request. What the listeners, or most listeners, do is they check the request and see, hey, can I do something with the request? Can I extract information from the request which is relevant for authentication? And that information, like passwords or like username or certificate IDs, whatever, they extract. That information is stored in so-called tokens. And then we have the authentication providers. And these authentication providers are then taking a look at the tokens and checking, hey, is that token something that I can validate, something that I can authenticate? And they are taking the username, for example, and looking it up in a database and checking if that exists or not, if the user is, if these credentials which were passed are authenticate or not. And they are using several other classes to do that. One thing are user providers. That's optional, actually, so they do not need to use user providers, but most of the time they do. And what the user provider is simply doing, it's simply a facade to your database, for example. Could also be in a memory store, but for PHP that's not so relevant. They are basically looking up the username in the database. But this is actually optional, because most of the time, or when I talk to people, that's not really clear that these user provider part is completely optional. So you do not need that for security to work. It's perfectly fine if you have an authentication provider which does not need user providers. Also to know, like if we are talking about providers, sometimes we're referring to authentication providers and sometimes user providers. So you really need to look at the context about which concept we're talking about, because it's two distinct things. Then the other thing is like the encoder. That's also optional, and basically what it does is it transforms your password like in a way that is not reversible, if you have a password in your user, of course. And then we have the user checker class, which basically does some things like, hey, is that user enabled? Are the credentials still valid, or have they expired, or whatever? And basically, it's performing checks. Is the user allowed to log in, actually? Or has it been like blocked or something? But that's also optional. Then, during the process, if the authentication provider, for some reason, decides, hey, I don't like that token, I can't let that go through, then it throws an exception. And what happens is then we are going to the authentication failure handler, which is basically transforming that exception into a response that can be displayed to the user. One more class is the session authentication strategy. So we have in the case if it goes through, like authentication provider is fine with it, the token or the information which is contained in the token is valid. Then what's called is the session authentication strategy. And what it does basically is some things like, hey, what should we do to the session? Should we like remove attributes or change the session ID? Should we generate a new session, or should we keep everything as is? Or also things like, hey, is the user allowed to have like 5 sessions, or should we only allow like 1 session per user account? All of that is done in the authentication strategy, in the session authentication strategy. And basically, it also can throw exceptions, in which case we also would land in the authentication failure handler. Yeah, let's go one further. The authentication success handler, like if the session authentication strategy is also fine, then basically the authentication succeeded. And where we go is the authentication success handler. What it does now is like transforming the successful authentication with the token into a response object. And that's basically its only concern that it ever does. One more thing is the remember me, which also hooks in that process at that point. Like if you have the response, the successful response, then the different remember me services are being called, and it's like, hey, do you want to modify that response, like add cookies or something? They have a chance to do that at that point. And 2 more things that I want to note here is the logout handlers. We actually have 2. That only applies to the logout listener. Like the logout handlers are doing stuff like, hey, can I delete the session, or do I have to delete a cookie? And the logout success handler is like generating the entire response that you want to display. What do you want to display? Do you want to redirect after the response? That is being decided by the success handler. Okay, that's about it for the authentication system. It was real quick. Now one more look at the authorization side of things. Basically, we have 3 entry points to the authentication authorization part of the system. One thing is the access listener, which also hooks into the firewall. And it's basically doing checks based on the pattern of the request, like what URL has been entered, or like IP-based matching, and doing checks based on that. Then, of course, we have one more entry point, which is the security context. And the security context basically can be called from anywhere in your code, like your controller or whatever. If you go like this security context is granted, then basically it's always going through there. Also, if you are having checks in your templates, like is granted in Twig templates, for example, if you're calling that function or is expression granted, then it's always going through the security context. And one last thing that you might not be so aware of is the method security interceptor, which is basically doing, if you're using annotations or other checks like which are AOP based, then it's going definitely through the method security interceptor. And that's basically inserting, like generating proxy classes for your real classes, and then calling a chain of interceptors to hook into the process. And that's all going through there. If you have a look at the cache folder, then you might see these proxy classes. So in all of these 3 entry points to the authorization system basically end up in the access decision manager, which then receives a request or a motion. Hey, what should we do with that? Can we allow this request or this authorization request to go through? And in the default implementation, we are using a voting-based approach, like in a parliament, basically, where we have different voting strategies. And if the motion comes in, the access decision manager asks several voters, like, hey, do you want this motion to be adopted, or do you want to grant access here? And we have 3 of these. This is basically the ACL voter, which is the facade to the entire ACL system. We have the role voter, which is role-based checks, and the authenticated voter, which just checks based on the trust level that we assign to the authentication token. And these use different classes each. So the ACL voter does use a permission map, which is basically a translation of the human-readable attributes like edit, delete, whatever you have there, to bit masks, which you do not want to remember or do not want to use in your code, like zeros and ones, which are very efficient for storing the permissions in the database. And that's basically what the permission map does. And then we also have the ACL provider, which basically knows which ACLs exist for each object. This also uses more classes, but I'm not going into detail here, like permission granting strategies and more like this. Then we have the role voter, which internally uses a role hierarchy, which basically internally uses a role hierarchy that allows you to do stuff like if the user has the role admin, then it also has like role editor or something like assigning roles to roles. And that's all normalized before we are doing any checks. And then we have the authenticated voter, which does check the trust level of the authentication. Like, is the user fully authenticated, or is it like anonymous, or is it a remember me user? And based on that trust level, you can also make or restrict access in your application. And then we have actually one more voter, which I want to show you, because that one is a bit smarter than the above voters. So this is the expression voter, which basically replaces all the 3 voters that we have. And the important thing to note here is that it basically, while the buff system is entirely like spinning up, if we get a request for access, then basically what the access decision manager has to do, it has to ask all voters or has to load all voters in order to make that access decision. So in the buff case, we are spinning up like if we have the ACL voter and the row voter and the authenticated voter, we have to spin up like all the dependencies of these voters as well, which is quite costly. In contrast, the expression voter directly talks to the different classes, and it does not talk to the facades of these classes. And one more thing, it does lazy load all of these dependencies. Like if you have no check that goes to the ACL system, then it will not load the ACL system. In the above case, the ACL system will always be loaded. Actually, you can look at some code there. Like if we have a controller class, let's call it post controller, and we have like 2 checks, like a post edit action or something. And we do like using annotations to check whether the user has access. So let's say we want that the user either is like authenticated or, and it should also have like the permission added for the post object. So in that case, basically, if you write something like this, then it would go right to the expression voter, which would first check, like, is the trust level, like, go to the authentication trust resolver and check, like, is the trust level of that token, which is currently in the security context, is that authenticated, like, is it remember me or fully fledged user? And if that doesn't work, if that is also already false, then it will basically stop there and not even load the entire ACL system. Only if that is true, then we will go and load the ACL system. On the other hand, if you had written something like this, like post edit alternative action, and you would write your code like inline, if this security context, let's say you have a property which has the security context, is granted, is authenticated, remember me, remembered. Basically, if you only write this, which is equivalent to the is authenticated expression in the first example, only if you write that, then basically what it would do is would load the entire ACL system, it would load the role hierarchy, it would load the authentication trust resolver, even though it doesn't need them, but it would load all of them. So that's really important to know if you're working with the security. It's better to go to the expression voter and use expressions than to use the hard-coded attributes, at least performance-wise. Okay, that's about it for the authorization system. Then I want to go into real-life world use cases, either questions that you have sent me or that I've been asked a lot of times when doing consulting, or which has asked on Stack Overflow or other platforms. So first use case, I want to test my application functionally. How can I test the parts that require a login? What should I do? Which method should I use? Usually, in that case, what I would recommend is to stay as close as possible to the method that you're using in your real world. Like, if you're using HTTP-based, HTTP Basic to access the application in the real life, if your user are using that method, then hey, also use that in testing. If you're, on the other hand, go through the form login, like if your users have to log in via a form, then you should also use that in your tests. Because like you don't want to test your application under conditions that's not being used under. And now some people can now say, hey, but slow. My tests are getting so slow, it takes ages to run them. That's especially true if you have like many of these tests. What I would recommend in that case is basically to split your tests into tests which are essential to the core functionality of your application, and always run these tests, and the tests which are taking a bit longer and which are not so essential, like every hour or something on a continuous integration environment, so that you basically get no penalty from logging into your application. Second use case. In my application, I want to customize what happens when access is denied. This sounds actually quite easy. Yeah, you send just a different response back, but it has some tricks which you can, or it has some faults where it can go wrong here. So basically, what happens if you're access denied? This could be either it always go through the exception listener, which is listening to the kernel exception event, which is something from the security component. We have two exception listeners. One is from the security component, and one is actually from the HTTP kernel component. And from the security component, what the listener does is basically checks for authentication exceptions, anything coming in, or access denied exceptions. So some people might say, hey, you just use another exception listener and check for access denied exception. One problem here is why you shouldn't do that. Basically, what you can see here, an access denied exception can either lead to like really access denial, like we want to show a page where we say, hey, you're not allowed to access this page, you have insufficient permissions, or it might also be the case that, hey, the user is not even logged in yet, so hey, let's give him a chance to log in, and maybe then we can grant him access to that page. So it might also go to the entry point. So that's point one, why you don't want to do that. The other point is you might have multiple firewalls. Like you have an API that you want to protect, and you have a normal page, like the default page that you want to protect. Now, if you use an exception listener, you have to basically first check, hey, which part of the request is being accessed here? Which firewall do we access here? And you might also go wrong there. So that's the second point why you shouldn't do it. And we have something better anyway, and that's basically the access denied handler, which the sole purpose of it is basically transforming an access denied exception into a response object. And basically, if you need to change the response that is being displayed to the user, then you should always go to that. I think also we have an example. Yep. So, okay. So basically, that's very simple. Just one method which you have to implement. You get the request object and you get the access denied exception, and all you have to do is you have to somehow arrive at a response. You can also, like, if your API is accessed, you can say, hey, I want to send back some JSON response or some XML response. That's also possible there, like using a serializer or whatever. So what I'm using here also is like annotations for the service, but you can of course use YAML or XML or whatever you like. So we have given this the service ID, default access denied handler, and what we still have to do is like wire that up in the configuration, and this is also really easily done. Like you can set an access denied handler for each firewall that you have, and just all you have to do is like put the service ID here. One more thing to note, I just want to go also, it's not really related to security, the public fault thing, because I still see a lot of people which are not using it. And basically what public faults does is it allows the dependency injection compiler to improve your code, to make it faster, to cancel out method calls which are required. So if you can put a public fault in some service, then put it on it. And most of the time you can, like if you do not retrieve a service from the controller, like this container get, then you can always put public faults in the service, and then you should do it, because it will lead to better compiled code in the DI container. Okay. So that's for, okay, what do we need? We need an access denied handler, and we need some configuration to wire it up, and that's basically all. And you will see that this pattern is used many times in the security component. So another use case, I want in my application to use the ACL system. How should I integrate it? Like, should I write checks in my controllers, or should I rather use annotations or other approaches? So what I would recommend is for basic ACL checks, use a listener-based approach. I think that works best. We also have like an example listener. So in that case, I'm using basically, assuming that you're using Doctrine, but William is here. It also works with Propel, of course, and no problems there. So just make sure that the listener is like running at the first possible point. What I'm listening for here is like the pre-update event, pre-remove event, and the post-load event. And it's really simple. We are injecting the entity manager, and we are injecting the security context. And then we are basically using expressions to check whether the user is authorized to access the different objects. Why you should do it like this and not in your controller is basically simply that if you do it like with the listener, then there's zero chance that any entity slips through and gets persisted or gets changed without ACL checks running. If you do not do it like this, there might be cases, because like also default in Doctrine is like to use to automatically persist your entities, so you do not have to call like this entity manager persist object. You do not have to do that if in the default case of Doctrine, but it's basically doing that automatically for you. So even if you have like not want to store an object, but have it somewhere in the request, or the entity manager is aware of that object, it might get stored, even if you do not explicitly call persist on it. So in that case, even with this approach, the change is not going through if the user has no permissions. One thing to note is that in that case, if you're doing that, then you might run into trouble with console-based applications, because by default, you do not have a security context in the console. So what we have to do is basically add something to the console, which is basically in a one-liner. We have to populate the console like with with a default context. Like the console code is like you're in your repository, and you can change it like you want. You basically have to add one line to populate the security context in the console context with a default token that you want to use there. The reason why this is not in there by default is basically that we would introduce a coupling on the console, like you could not deactivate the security bundle otherwise. Like then you would have exceptions because the security context service does not exist. So you have to add that line yourself, and we cannot do it for you like beforehand. Okay, how to use that then? If I have the default context in my console, but now I'm getting, like, let's say you have a fetch feeds command, which fetches like a Facebook feed for a user or something, and you basically have a service like feed fetcher, and you call the fetch feeds method on it to fetch like the feeds for all users that have registered on the application. So let's go into the service. So fetch feeds basically is getting all users and then iterating over the users and fetches feeds for them. And if it has new feeds for that user, it basically converts to them, checks, do we have that post already in our database, and maybe something has changed, like new likes are coming in or new comments or whatever, and then it's basically updating it. And if I call the persist method, if I call the flush method, then basically all these ACL checks are running through, and in the console context, this would be called with an anonymous token, so like ACL checks wouldn't work. Or they would fail and you would get an error or something. So one thing to note is like like this line here. Like we're running this method, basically what we're saying, we want to run this method. For the invocation of this method, we want to run basically, or we want to bypass all security checks. Like this basically also assumes that you're using the superadmin voter. So this is a special role which gets added by that. And basically, it can bypass any security checks. So for the invocation of the fetch feeds method, you can basically do anything security related in the application. All security checks will always pass. Yeah, you could. You could call the service, which basically the run as annotation uses, and do that manually, sure. But you would have to inject it. It's called the run as authentication manager or something. I don't know the exact service ID, but you could call that manager yourself, and then basically, do it manually. Okay. So that's for ACL. Next use case, in my application, I do not want to use an ORM, but receive all user details from an API. Like I have a Java-based application which holds all my data, which is very performant, and I just want to use my Symfony 2 application as a front end. How can I do that? And basically, yeah, what you need is, first you need to exchange the authentication provider, and you also need to write a bit of configuration. So this is really simple. It's just one class, API login. So basically what we do here, let's assume that you have an API client. It's some service that you inject here. And the key is, in that case, the name of the firewall that you have. And basically, it looks like any of the other providers that you also have. Like we are first checking, do we support that token? Does that token belong to this firewall which is being accessed? And then we basically call a method on the API client, which would then call, or actually call a method on the Java application. And we are basically passing the username and the password, which is stored in the token. And we are passing it onto the Java application, which then performs some checks, whether the user's credentials are valid or not. And if that goes wrong, like the user password and the authentication, the password and the username are not correct, then basically we can throw an exception right here. We do not need the entire user provider or user checker or encoders, so that it's not necessary. You do not need to use that, because I've seen that often, the question, hey, I do not have a password, it's being sent to the Java application, I do not know how to encode it, what should I do? So the answer is, like, use an authentication provider. Do not use a different user provider. That would be the wrong level. And then basically you can also do things like retrieve details from the user, like any user information basically that you have on the user, you can retrieve it from the backend and then store it in the token. So that's really simple. It's like 36 lines of code, which is not much, and then you have basically API-based authentication in Symfony. Other use case, in my application I want to allow login via AJAX. Like, I have no normal, if someone submits the form, then basically, yeah, it's sent via AJAX in the background and not like a real request that the user sees. What do we have to change to accomplish that? Basically, we changed the authentication success handler and the authentication failure handler. Now, we have seen the authentication success handler. What it does is basically converting the successful token into a response, and what the failure handler does, if an authentication exception happens, then it's converting that into a response. That's also really simple. You can look at some code here. It's like 3 classes, like an AJAX failure handler. So we are basically first checking, is that an XML request, an XML HTTP request? Like, is it requested by AJAX, or maybe it's a normal request? Then we ignore it. And if it's an AJAX request, we just send back a JSON response. Now, you shouldn't do that right here, because basically you shouldn't do this part, because the message could contain some information that you do not want to display. So you should have a filter here. But apart from that, basically, that's what you need. And then we have also the AJAX success handler, which looks quite similar. We are checking, like, is it an XML HTTP request or is it not? And if it's not, then we ignore it basically. And how do you wire that up in the authentication, in the configuration? Basically, all you have to do is basically add for each method, for each authentication method, you can define which authentication success handler and which failure handler you want to use. And basically you, like for the access denied handler, put the service IDs there. And that's about it. And then you have AJAX-based authentication in your application. Another use case in my application, I want to have localized path for login. That's something because we do not have like the capabilities in Symfony 2 itself to do I18N-based routing, that this is not so easily done if you're solely depending on Symfony 2. My recommendation, like if you have a sample, let's assume you have a sample application or a configuration which looks like this. It's pretty simple. Like you have form-based login, and you have basically the login path is the login route, and the check path is the login check route. Now all you have to do basically is to install another bundle, and then it works like right out of the box. Like with that bundle, JMS I18N routing bundle, if you install it, then you automatically have E18N routing for your login path and for your check path. Now, if you don't want to use that bundle for some reason, which is perfectly fine, then basically what you have to do is copy what the bundle does, because otherwise there's no real way to do it. I think there's also another bundle which you can use. Now let's see if you don't want to use I18N. Like for the login action, I want to use I18N because like the user is seeing this route. But for the check pass, it doesn't really matter to me. Now, if you wanted to like deactivate it for it, then we would have to add like options and I18N false, and that's basically it. And then you would have deactivated I18N for this specific route, and yeah, it would be using the non-localized path for it without changing anything in the security configuration. So the security configuration always stays the same, and you do not need to do anything there. I think we have one more example. Yeah, exactly. What needs to be changed? Configuration only. So that's really so simple. Last use case. In my application, I want to offer multiple login options like Twitter, Facebook, and also form login. How should I do it? How should I implement it? Let's assume that you have a database schema which looks like this. Like you have a user object, which has a username, a password. Username could be an email address. And you have like multiple accounts which are basically one-to-one relations to these, like a Facebook account where you store the Facebook ID, and a Twitter account where you store the Twitter ID and probably more information like the OAuth token and whatever you need there. How do I wire that up in the application? What do I need to change to make that happen? Now, basically, we need to change a bit more classes here. Like we changed the entry point, and we changed different user providers. We're going to look at actual code here. So let's start with the entry point. Basically, what we need is an entry point which is capable of starting authentication for all of the login options that we want to use. So we're injecting here the Facebook entry point that we have. We're injecting the Twitter entry point, and we're injecting the form entry point. Then we are basically, Then we are basically looking which route is being accessed and which entry point should we trigger now. And if the Facebook login route is matched, then we trigger the Facebook entry point. If the Twitter login route is matched, then we trigger the Twitter entry point. And by default, if none of that matches, then we send the user to the login form, where we can also display the login options for the Facebook and Twitter, for example. So that's basically the default entry point. How do we wire that up in the configuration? It's a bit longer here. So basically, we change one line, like entry point, and we give it the service ID of our default entry point. And then we're also using, we have different user providers. Like we have one user provider for Facebook, we have one for Twitter, then we have an email-based user provider which we use for form login, and by default we are using an ID-based provider in our application, which basically looks up your user based on the ID. This is the default one. And then we have, like for Facebook, we're using Facebook, and for Twitter, we're using Twitter, and for form, we are doing an email-based lookup. So you can log in with your email in the form. So how do they look? Like the ID-based provider and the email-based provider are very similar. Oops. So all it does is basically a query, and it's selecting a user either based on the ID, or it could also be like if you have the email-based provider, it would do the same thing, but with using the email. Same method. So the ID is being passed here. And then it's basically either returning a username not found exception, like throwing it, or it's returning the actual user which exists in the application. And for the Twitter user provider and the Facebook user provider, which are also similar, we are using a bit more. Basically, we're doing a lookup, like the query is a bit more complex here. We are doing a join, and we are checking, and we are selecting the user which has the appropriate account associated, and then returning null. But if it doesn't exist yet, then we also have the option to create that user. Like if a user logs the first time in and clicks on the Twitter, I want to log in with Twitter, then we also want to create that account if it doesn't exist yet, so the user has the best possible user experience. And what this allows here is basically, if the token does not exist, the authentication provider of the Twitter, authentication method is basically calling the create user from access token method, and we're basically creating that user, setting up the user account, and then persisting it and returning it. Okay. So for Facebook, that looks very similar. Like you have also a Facebook user provider which can create the account if it doesn't exist yet. And we have different login paths. Like we have one login check. Let's look at the security controller. Like we have a third-party login, and all we are doing there is we are throwing an access denied exception, which then in turn triggers our entry point. which then checks which route is being accessed. Like if the Facebook login route is being accessed, then we're triggering the Facebook entry point. If the Twitter login route is being accessed, we're triggering the Twitter login entry point. For login check, it's about the same. The difference is just that we are triggering the authentication listener for that authentication method. But apart from that, it's the same. So now you might say, okay, now we have created that user, but I also want the user to enter his email address even if he logs in via Twitter. How can I do that? So then we use an extra listener, which is basically enforcing that the user is complete if he wants to access any page. And what it does is basically listen to the kernel request event, and it's checking, hey, do we have a user in the security context? If not, then basically I'm bailing out here. I'm not going further. Is the user already complete? Like, has he entered his email address already? Has he entered his password or whatever? If you want to enforce that, basically you can do whatever you want in this complete method. But if it's already complete, then we're also out here. And if it's not complete yet, then basically we're forcing a certain controller to be always called. In that case, we are forcing like the account controller from inside the user bundle and the complete action to be called. Like the user cannot access any other page unless he has completed his account first. So that's also possible here. One more thing here, like if you want to allow users to link multiple accounts, like a Facebook account and a Twitter account, to the same user, then you basically need to do that without using the security component. So you can use the security component for the first account that he creates. Like if he logs in the first time via Twitter, then we can create the user account. If he now wants to also log in via Facebook, then you basically need a separate action where you allow him to link his Facebook account. It cannot go through the security component as well. Basically, it wasn't designed to do that. So that's an important thing to remember here. I think, yep. We are at the end. Thank you very much.